Now I am going to solve some textbook problems. First problem. A source producing a sound of frequency 90 Hz is approaching a stationary listener with a speed equal to 1/10 of the speed of the sound. What will be the frequency heard by the listener? What will be the frequency heard by the listener? Right. So in this problem, a source moving towards a stationary observer. Source moving towards a stationary observer. The given data in the question is, first one, the actual frequency of the sound wave emitted is n, which is equal to 90 Hz. Next, the speed of the source is 1/10 of the speed of the sound. The speed of the source is represented by Vs, which is equal to 1/10 of the speed of the sound. Speed of sound is represented by V and the speed of the source is represented by S. From the given question, the speed of the sound is equal to 1/10 of the speed of the light. Right? What we want to find out? The frequency, apparent frequency heard by the listener. Apparent frequency heard by the listener is n prime. Right? And here, observer is at rest. So VL value is 0. And the formula for apparent frequency as the source moving towards a stationary observer is n prime is equal to V divided by V minus Vs into n. Right. And V velocity of the sound divided by V minus the velocity of the source is equal to 1/10 of velocity of light. So 1 divided by 10 times of V into the actual frequency of sound wave emitted by the source is 90 Hz into 90. So V divided by 10V minus V, 9V divided by 10 into 90. Like V cancel, 10 goes to numerator. So 10 divided by 9 into 9. 10 times 10 into 10, 100 times. The original frequency of the sound wave emitted by the source is 90 Hz. When the source moving towards the stationary observer, the frequency of the sound wave heard by the listener becomes 100 Hz. 100 Hz. Right. Is moving with a velocity of 50 meters second power minus 1 towards a stationary listener. The listener measures the frequency of the source as 1000 Hz. What will be the apparent frequency of the source when it is moving away from the listener after crossing him? Right, the velocity of the sound is given, that is 330 meters second power minus 1. Right. So in this problem, you want to use two formulas. First, two apparent frequency formula. First formula, the apparent frequency of the sound wave when the source is moving towards the stationary observer or stationary listener. Second formula, apparent frequency of the sound wave as the source moving away from the stationary observer. Right. So first, given data, the given values are the velocity of the source Vs is equal to 50 meters second power minus 1. And next, since listener is stationary, so VL value is equal to 0. The listener measures the frequency of the source as 1000 Hz. That is apparent frequency value is 1000 Hz. That is n prime is equal to 1000 Hz. Right. From these given values, first we need to find out the actual frequency of the sound wave emitted by the source. Right here, source is moving with a velocity of Vs, whereas the listener is at rest. So VL equal to 0 in first case. Right. Apparent frequency formula, n prime is equal to V divided by V minus Vs into n. N prime value is 1000 and V value also given, that is 330 meters second to power minus 1. So 330 minus 330 minus Vs value is 50. And then actual frequency. Right. Then 1000 is equal to 330 divided by 330 minus 50, 280 into n. 0 cancel. Right. Next 1000 into 28. 28,000 divided by, therefore n equal to 28,000 divided by 33 hertz. So this is actual frequency or original frequency. Right. Next, what will be the apparent frequency of the source when it is moving away from the listener? Moving away from the listener. Right. Right. Now a new apparent frequency is taken as n double dash, which is equal to V divided by V plus Vs into n. N double prime is equal to V divided by V plus Vs into n, because the source is moving away from the listener. So as the source is moving away from the listener, the apparent frequency is given by n double prime is equal to V divided by V plus Vs into n. Right. V value 330 plus Vs value 50 into the actual frequency is 28,000 divided by 33. Then 330 divided by 330 plus 50, 380 into 28,000 divided by 33. Cancel. 33 cancel. Then 28,000 divided by 33. 736.8. If the source is moving towards a stationary listener, the apparent frequency of the sound measured by him is 1000 Hz. If the same source crossing him, then apparent frequency measured by him becomes 736.8 Hz. Problem. At what speed should a source of sound move away from a stationary observer so that observer finds the apparent frequency equal to half of the original frequency? Half of the original frequency. So, what speed should a source of a sound move so that the apparent frequency measured by him is equal to half of the original frequency? We need to calculate the speed of a source. Speed of a source. Apparent frequency is equal to half of the actual frequency. Half of the actual frequency. Here, the listener is at rest. So, VL is equal to 0. We need to calculate the speed of the source or velocity of the source. Right. Here, source is moving away from the stationary observer. Therefore, apparent frequency formula n prime is equal to V divided by V plus Vs into n. Right. Here, given value n prime is equal to half of n. So, put instead of n prime 1 divided by 2 into n. It is equal to V divided by V plus Vs into n. Right. N cancel. Right. Cross multiply V plus Vs is equal to 2V. Therefore, Vs is equal to 2V minus V. So Vs is equal to 2V. That is the velocity of a source. The velocity of the source should be equal to velocity of the sound. Velocity of the sound. Right. Then only the apparent frequency becomes half of the actual frequency. Apparent frequency becomes half of the actual frequency. Next, problem number 4. Air temperature in the Rajasthan desert can reach 46 degrees. What is the velocity of the sound in air at that temperature? V naught is equal to 331 meters second power minus 1. What is V naught? The velocity of a sound at a 0 degree Celsius value is given, that is 331 meters second power minus 1. We need to calculate the velocity of a sound in air at a temperature of 46 degree. Right? 0.61 into T. Right. And V naught value is 331 plus 0.61 into the temperature is 46 degree Celsius. Right. The V naught value is 331 meters second power minus 1 and temperature T is equal to 46 degree Celsius. So these two are given values. The required formula for this problem is Vt is equal to V naught plus 0.61 into T. Now substitute the known values or given values. V naught 331 plus 0.61 into temperature is 46 degrees Celsius. Right. Then 331 plus 28.06. So 331 plus 28.06, 359. The velocity of sound at 0 degree Celsius is 331 meters second power minus 1, and if the temperature of the air medium is 46 degrees Celsius, then the corresponding velocity of sound wave in that temperature is 359.06 meters second power minus 1. Right, next problem. A man is standing between two vertical walls 680 meters apart. He claps his hands and hears two distinct echoes after 0.9 second and 1.1 second respectively. What is the speed of the sound in the air? What is the speed of the sound in the air? Right, a man. Two walls. This is first one. This is the second one. The distance between the two walls is supposed to be, okay, it is given 680 meters. The distance between the two walls is 680 meters. A man is standing between these two vertical walls, and the distance of the wall from the man, the distance of the first wall from the man is taken as D1. And the distance of the second wall from the man is taken as D2. And the echo times for the, reflected from the two walls are given. One is T1 is equal to 0.9 second, and here T2 is equal to 1.1 second. 1.1 second. So from these given values, we need to calculate the velocity of the sound in air medium. Velocity of sound in air medium. Right. So from this figure, the distance between the two walls D is equal to the sum of the distance of the first wall from the man and the distance of the second wall from the man. That is D1 plus D2. Right. From this diagram, the total distance between the two walls D is equal to sum of the distance of the first wall from the man and the distance of the second wall from the man. That is D is equal to D1 plus D2. Right. We know that velocity is equal to 2D divided by T. From echo method, the velocity of a sound wave in a given medium is given by the formula V is equal to 2D divided by T. Right. Therefore, D is equal to V into T divided by 2. D is equal to V into T divided by 2. Right. When the sound wave travels, okay, in the left direction or the right direction, its velocity does not change. But time taken, echo time in this direction is T1 and echo time in this direction is 1.1 second. So therefore, D1 is V into T1 divided by 2 and D2 is equal to V into T2 divided by 2. D1 is equal to V into T1 divided by 2 and D2 is equal to V into T2 divided by 2. Substitute D1, D2 value here. D value is 680, which is equal to V into T1 divided by 2 plus V into T2 divided by 2. Right. So V1 T1 or V T2 divided by 2. Right. V divided by 2 of T1 value 0.9 and T2 value is 1.1. So V by 2 into 0.9 plus 1.1, 2 cancel. This is equal to 680. So therefore, echo time, okay, from the first wall is 0.9 second, and echo time from the second wall is 1.1 second, and total distance between the two walls is 680 meters. So by using this condition, we can calculate what is the velocity of the sound traveling in air medium. That value is 680 meters second power minus 1. Right, last problem. The thunder of a cloud is here 9.8 seconds later than the flash of lightning. If the speed of sound in air is 330 meters second power minus 1, what will be the height of the cloud? What will be the height of the cloud? Velocity of sound or speed of sound in air is 330 meters second power minus 1. We need to find out the height of the cloud. Height means distance. Right? Velocity is equal to distance divided by time, or height of the cloud divided by time. Right? Therefore, height of the cloud h is equal to v into t. Velocity value 330 and time value is 9.2. 30 into 9.8. 3